Alright, so here's the next problem. Length of the longest valid substring. You are given a string word and an array of strings forbidden. A string is called valid if none of its substrings are present in forbidden. Return the length of the longest valid substring of the string word. And then a substring is a contiguous sequence of characters in a string, possibly empty. So here are some examples. cbaaaabc, and then here are the forbidden ones. So you can see there's 11 valid substrings, and this is the largest, so it wants to return a 4. Here's another one, Leetcode. Here are some of the forbidden sequences. You can see here are the possible substrings. Constraints, the word length will be between 1 and 10 to the 5. Only lowercase English letters. 1 is less than forbidden length, which is less than or equal to, or 1 is less than or equal to forbidden length, which is less than or equal to 10 to 5. And then 1 is less than or equal to forbidden length of I, which is less than or equal to 10. So this is pretty important, that you'll never get more than, none of the forbidden words will be longer than 10 characters long. And they could be as small as 1. So basically, this list of substrings is sort of trying to lead you on the wrong path. What you actually want to do is you want to have a test sequence where you go backwards. We have a window that's moving backwards and growing to try to figure out what the maximum. Like you don't want to figure out you don't want to list every substring, you just want to find the maximum one. So for example, for this, what we want to do is we sort of want something where it first tests C, because that's the last one, and then you test B and BC, and then you want to go one more, so you're going to test A, and then AB, and then ABC, and then one more, so AA, AAB, AABC, and what you can do is you can start to have sort of a right wall then. So at some point you can stop testing. So you see sort of how that works. So the first thing we want to do is, let's take this forbidden, and we want to turn it into an, how do I spell this, unordered. You want to turn it into an unordered set because it's going to be quicker to look up, because this is basically a hash map. Say forbidden, and we'll say f dot begin and f dot end, because that's going to turn this forbidden vector into an unordered set, so then you can just check it like it's a hash map instead of having to iterate over it each time. The next thing we're going to do is we're going to start iterating backwards. So we'll say and I is equal to the word dot size minus 1, I is greater than or equal to 0, I minus minus. And then the next thing we want to do is we want a temp string, and we're going to say for int window size is equal to 0, while your window size plus I is less than, what is this? Less than or equal to word dot size, window size plus plus. So this is going to do is, this is going to be moving to the left while your window size is increasing. So we're going to semicolon here. You're going to say temp plus equals, I'm going to initialize this, equals word dot at I plus window size. So that's sort of the element that you're checking. So what we need to say is if temp, we need to check if this temp is within the forbidden. So how we'll do that is we'll just say forbidden dot count temp. sort of how this evaluates is if the count, if it does exist, the count will be non-zero, whereas if it doesn't, it'll be 0. So this is basically the same thing as saying exists. Just exist doesn't work, so we say count. So what we're going to do in longest is equal to 0. So if the forbidden, so if this is forbidden, there's another thing we need to do here. And right wall is equal to word.size minus 1. And we also need to check in here. Really, we need to check if, and we need to check if, yeah, so we need to check if it's past the right wall. I feel like something's wrong here. I feel like there's an off by 1 error. Should have written this down ahead of time. Let's just keep going and we can debug the off by 1 error later. Alright, so what we have here, we have a right wall, we have a longest, we're iterating backwards over the string. And then increasing window size. So we have, so if this is it, it's a forbidden word. So actually what we're going to do is we're going to start, I know I'm going to have to debug this somehow. So we're going to say add this here, print f, forbidden. So if it's forbidden, what you need to do is break because you know it's no longer valid, and we need to move the right wall to, so we don't want to set it to I because you can go, so like if the string is A, B, C, D, you can, and B, C, D is not allowed, you can still iterate A, B, and C, it's just D you can't do. So really what you want to do is you want the right wall to be the last element that would complete the word, not the first. So it's going to be I plus window size. And we'll break. Otherwise, if it's valid, we'll say longest is equal to max of longest. And window size plus 1. Gosh, I feel like something's wrong here. All right, so let's go over what we've got here. We're converting to a map. We're initializing the right wall. We're iterating backwards over the string. We create a temp string, and then we're adding to that temp string for each of these elements. We are then going to say if it's a forbidden word, you move the right wall forward, and then break. And then on each iteration, we're updating longest. So let's just run this and see where it breaks. Oh, so we need a, so it's a constant character array is what that is. Return longest. All right, cool. So let's submit it now and see what happens. It says judging output limit exceeded, so it doesn't like that we have all these printf statements, so let's just comment them out and resubmit it. All right, so you see time limit exceeded. So we need a way to optimize this. So if you can tell, this is important here. The length is never going to be greater than 10. And if you look at this where the time limit exceeded, you see how it's just a bunch of A's. and this is BC, DE, B. So really we don't want to increase the window size up this entire thing. What we can do is we can check if the window size is above 10, and if it is, we can assume that you can complete all the way to the next right wall without checking it. So what we'll say here is, or how we'll do this is we can just check if the window size is greater than 10, because it's the max length you can possibly get. We know that the value is going to be, let's think about this for a second. So it's going to be the right wall minus the current index. You know that's going to be valid because you don't need to check. So if I is let's say 30 and the right wall is whatever that number is, you don't need to check every single one in between there. You just know that the difference is all valid. So what we can do here is we can say the longest is equal to the max of longest and the difference between the right wall and I, so that we don't have to iterate over each of these elements. Time limit exceeded, that's not good. Oh, so we need to break. There we go.